Alrighty, we got here a classic particle motion question from 2011. So they give us an equation for the particle's velocity. They give us an equation for the particle's acceleration, not the position, but they do give us this initial condition. So the particle is at position at 2 units from the origin when time t equals 0. Alrighty guys, so the first part says, is the speed of the particle, okay, we're talking speed, increasing or decreasing? So is the particle speeding up or slowing down? And to answer a question like this, you need to look at v of t, you need to look at a of t, and to decide if the speed is increasing or decreasing, you need to know if they have the same signs or different signs. So we need to look at the signs of a of t and v of t. So up here you see a little screenshot from my calculator where I used v of t as y1 and a of t as y2. So now I'm going to go to my calculator and I'm going to check out v of 5.5 and I'm going to check out a of 5.5. So I'm going to pause the video for a second. I'm going to go plug those into my calculator and let's see what it looks like. So I went to my table and my calculator and I have my independent variable set to ask and I plugged in a 5.5 and whenever I did that I saw that v of 5.5 is a negative 0.453 while a of 5.5 is a positive 0.1816. So to answer the question, is the particle speeding up or slowing down at t equals 5.5? I would say that the particle is slowing down, or its speed is decreasing. So the answer to part A is the particle's speed is decreasing at t equals 5.5 because a of 5.5 is greater than 0 and v of 5.5 is less than 0. So that shows they have different signs, so therefore this particle is slowing down, aka its speed is decreasing. Part B says find the average velocity. So when I think average velocity, and I have the velocity function, it makes it really, really easy to work this problem. Remember, when you have samesies, velocity, then I'm really just saying, hey, what's the average value? So I will be busting out the average value formula. So that's my average value formula, and I'm doing that because it asks for the average velocity, and it gives me the velocity function. So I'm going to, for part B, I'm going to write out the average velocity function. The average velocity is 1 over b minus a. So if we're going from 0 to 6, that's 1 over 6 minus 0 times the integral of 0 to 6 of our velocity function. And I'm just going to write v of t dt to save time. And then I'm going to go to my handy dandy calculator. So my calculator did all the hard work for me. And I know that the average velocity, 1/6 times that integral, is going to be equal to 1.949. All right, remember to go to the thousands place. And there we go. Cool. So part B is Dunzos. Number C, find the total distance. Okay. So the last problem said average velocity, which automatically triggered something in my brain. This question says total distance, which also triggers something in my brain. When I see total distance, I automatically think the integral of the absolute value of my velocity function. All right. So for part C, I want the total distance traveled by this particle. It's going to be equal to the integral, the absolute value of v of t dt from 0 to 6. So let's go to our handy dandy calculators and plug that in. All right, so again, my calculator did all the hard work for me. And after I typed that integral in, it gave me a value of 12.573. So the total distance that my particle traveled was 12.573 units. Okay, cool. Part D. Part D says the particle changes direction exactly once. Find the position of the particle at that time. So cool, there's multiple things going on in this problem. Number one, I got to find the time that the particle changes direction. And then number two, I've got to find the particle's position at that time. So the first part, we need to find when the particle changes direction. So changes direction. So we should remember from our notes, we have a really good set of notes here. The particle changes direction when its velocity changes signs. V of t changes signs. So we need v of t to change signs, and I'm going to use my handy dandy calculator, and I'm going to look at the v of t graph and see when it changes from being positive, negative, or negative to positive when it crosses the x-axis. So hold on a second, and I'll show my calculator. Alrighty, so I graphed the velocity function. I got rid of the acceleration function, didn't need it. So we see the velocity function, and you can see where it changes signs at, and I calculated it. So at x equals 5.195. So at t equals 5.195 seconds, the particle changes direction. So right here, at time t equals 5.195, and let's keep that going as long as possible. Let's store that in our calculator so we can have the most accurate answer as possible. We'll store that. And so now I've got to find, we'll store it as A, okay? We'll say, hey, that's A. That's when the particle's changing directions. And we want to find the particle's position at that time. So I'm going to have to write a little integral to go backwards from the velocity to the position. So let's do that. Changes direction. At t equals 5.195. And there's more stuff that goes with that, so I'm going to store that as A. And then I'm going to write an integral. So I'm going to write that so I stored that 5.195 blah 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 as A so I could have my most accurate answers possible. And now I'm going to write a little integral to figure out what the position is at that time. So at x of, I call that A, that 5.195. At x of that time, the position would be the change in distance over that time period, so 0 to A, plus whatever I started at. So because I started with an initial condition up here, I started 2 units away from the origin. I've got to add that, plus the 2 units that I started away from the origin. So let's make sense of this. This right here tells us how far I traveled in that time period, and this piece right here tells how far I started away. So I traveled that much, and I was already that plus 2 units away. So that'll tell me where I end up. So I need to go to my calculator real quick and plug in all that good stuff to see what my position is. All right, and I plugged all that in my calculator, and I found that I'll have a position of 14.134. So I'm that many units away from the origin at the first time I changed direction. So cool. So you can see that my calculator did a lot of work for me. I just had to know the concepts. I had to understand some pretty big ideas in this problem. I had to understand, first of all, the idea of speeding up or slowing down based on the signs of A of t and V of t. I had to understand the whole idea of average velocity when given a velocity function. So I had to understand that that was just average value, because I was looking for average velocity given a velocity function. It was the same function, the same thing. I also had to understand what the total in total distance meant. And then lastly, I had to understand how to work backwards from velocity to find position. And I had to make sure that I included my starting point. So a lot of really cool stuff on this problem. I hope it helped. I hope you got smarter. And I hope you can rock all these FRQs. See ya.